Chill out a bit. There we go. I don't mind it in the background, but it's too much. And you might hear a lot. Oh, Kitty, you alright? My poor cat's having a bit of a fit because there's loads of fireworks. Come say hello. No? Just, we've tried to give her some calming spray. Basically drugs, innit? It's like, I don't know what it's full of, but it's meant to chill him out, but it's not worked. Maybe we can put it down the throat. No, it's not very nice. What am I talking about? Yeah, so I was just, do you hear that? That's a firework. That's what's happening. So we're not doing this at all, what I'm got on the screen, so don't get your hopes up. I don't know why I said that. What was I looking at here? I don't know. I was looking for a blog post, but I couldn't find it. Anyway, yesterday we're going through this. Advert number 1. Get this book. But Sandy was kind enough to say we could just, stream the book, which is cool. And in this chapter, well, we did the first chapter, which was cardinality and something else. I think it's just cardinal. Should we go back up? I'll go up here. Where was it? Introduction. Chapter 1 was algebra behind types. Oh, okay. Oh, so that's what it was named. But really, it was like doing all the cardinality. Oh, it's the best time to... Can you hear that? Wee. Streaming. It's great. Streaming. Fireworks. And I think the first one was a bit more... Whoa. Hello. Well, it just makes it... Oh, hold on. Oh, I don't... We need someone to come and like... what do you call it? Follow. Is it follow? I've created a new follow animation. I'm just going to show it to you. Because I don't think anyone's going to follow tonight. So, let's do it. I think it's on Stream, isn't it? Streamlabs. Let's go on Streamlabs. Where's my cat? You're there. Kitty, it's just... Ow. No, she's having a mental... Kitty! I feel bad because she's just kind of like crawling on the floor thinking she's being attacked. And it's bloody lockdown. Why aren't you... You're meant to be at home. Relaxing. Not setting off fireworks, you sods. Everyone's doing fireworks. What was I going to say? Oh, look, here we go. So there's a reason to this. We'll go in here. You ready? Where is it? Follow. Here it comes. Oh, god damn it. That's bloody loud, isn't it? That one. Okay. We need to rethink this. That was so loud. Where's the volume? Yeah, I have to have it like right down here. Shh. There we go. It's a bit late. Don't go so loud. Right, let's get into things. Stuff all this experimenting. Didn't work. Yes. Have I put a link to that? Yes. Buy this book. Well done. No, it's good. Joking aside, it is good. I showed yesterday, but I've got a hard copy of it as well. For those. Not forgotten about this. Can I... Hold on. Maybe I can... I'm not going to play with it. But yeah, I hope people went out and experimented to see... Monoidal. Okay, we're not going to start this again. Let's go to the code. Where are you? There it is. We're on... okay, so we did that. We did this. We got to the end. We did the empty board tic-tac-toe. And then we had a look at this. And it got confusing very quickly. But it kind of made sense. And then we're going on to this. The kind system. So, you'll see. Because if we use cardinality and then the kind system... they come in handy later, as I found out the hard way. And yeah, is the font big enough? I think it's big. Yeah, it looks big enough. I kept it the same as yesterday, so I know this is big enough, but I'm never sure about this. But let's do it. So in everyday Haskell programming, the fundamental building blocks are those of terms and types. Okay, terms are the values you can manipulate, the things that exist at runtime. Okay, so terms is runtime stuff. Types, however, are a little more than a sanity check. Yep, which we know. Proofs to the compiler and ourselves that the program we're trying to write makes some amount of sense. I mean, that's questionable, but it should do. Completely analogously. I feel like this is gonna. Yeah, maybe I shouldn't read this stuff out. I don't know why I struggle with. Yeah, I can read it, but you can see it. Yeah, I must have. I've got to be dyslexic. I've got to be. Definitely what it is. The fundamental building blocks of type-level programming are types and kinds. Except, so where did it say? Terms. Terms are runtime, but it's not really explained what kinds are. Okay, the types now become the things to manipulate, and the kinds become the proofs. Okay, so the types now become the things to manipulate. So the times are the things that we over here. So not runtime. Before compile time, I guess. And the kinds, they are the proofs of those types. We used to keep ourselves honest. Okay. I mean, I try not to lie, apart when I'm trolling a bit. The kind system, if you're unfamiliar with it, can be reasonably described as the type system for types. Okay, that makes more sense, doesn't it? So what essentially that means is once you start messing with kind system, you're doing the functionality within the types. So we'll see later, but basically the way I sort of thought about it was look, it just says it here, it's types of types, but also you can like make functions and stuff within the types, which is pretty damn interesting, isn't it? But that line of reasoning, then kinds are loosely the types of types. Yeah, with a number 1, which is this will particularly be true when we later look at what chapter is that? 15. Definitely not got onto that chapter. So consider the numbers 4 and 5, both of type int. As far as the compiler is concerned, we could replace every instance of 4 with 5. Yeah, because the compiler's not going to care, is it? It's just going to think, whatever you give me, all I care about as a compiler is that it's an int. Unless you start doing some case matching and stuff like that. But as a high level, it's only going to be concerned about the int. And the whole thing would continue to compile. Yep. So the idea is, that's how you can have, that's how we do lots of interesting functions in Haskell, because they can just take any number or whatever, any int, etc. Okay. So the whole thing, the program itself might do something different by virtue of both being a type int. 4 and 5 are interchangeable. Okay, at least as far as the type checker is concerned. Yeah. So when literally when we run Haskell language server, that's when we hit this sort of stuff, don't we? We're just like, oh, hello. That's when we're testing our compiler. So we can do that. There we go. And what it returns here is because it's testing, it knows by up here what these types are, i.e. what's meant to be returned down here, which was nothing from memory, especially spelled incorrectly. Cool. So the word type can be used to describe anything that exists at the type level, which is to say anything that is neither a term nor a kind. I think, the confusion, it does explain it. I don't know, it doesn't say it here, doesn't it? Yes, I should have read that bit first. Before continuing our discussion, we must sidestep a potential point of confusion. Rather perplexingly, which means rather annoyingly, there are several related meanings that fall under the word type. Yeah, this is a confusion. So you get type, level, and all this. Yeah, and it will explain. We will need to differentiate between two of them. The word type, so in lowercase, can be used to describe anything that exists at a type level, which is to say anything that is neither a term nor a kind. So the term was runtime, and the kind was the types of types. Yeah, okay. However, we can also refer to types, which is in uppercase, but when you use it within Haskell, it's like that. Okay, but I think he does it on purpose to sort of differentiate the two, which is the kind of types that have inhabitants. Historically, type has been written, yeah, so before you'd see things like this, like that. But because things are moving over, you're probably a lot better off from now on, which is what this book does, thankfully, is just do that. And then you'll see if actually, let's just save it. Probably can't use it at this level. Okay, we won't. Just leave it for a minute. We end up bringing stuff in anyway. Hold on, what have I done? We want to close this one down. And we're going to create a directory. And we're going to go for... don't create from there. Oh, no. Create from here. What we're going to call it? Chat 02. Cool. And then we're going to create a file. We're calling it chapter 02. Yeah, I want to sort of split it up. And then one word please. Where is it going to be happy? It won't be happy because we also need to go in here and do that. So we'll do YYP and we'll replace that with a 2 and we'll replace this with a 2. Lovely. And then we'll... Oh, we've not even done anything. Let's save this for a moment. Oh, look at the naming of it. Well done. It's not even going to know what files it is it? And especially if it's not an LS. Okay, cool. Now it's loading, see, and it's recognised it. Well done, Vince. You just created a file called chapter 2 dot nothing. You didn't even have a dot. I've got a feeling I didn't make enough juice. Oh well. If I get too thirsty, I'll go fill it up. Oh, I need to move it out of the way because I can't see it then. Okay. So we're in chapter 2. So we've created that. That's all working, and we'll get rid of that. Get a bit more space. Okay. And we just explained that bit. It used to be star, but this older notation is slated for the deprecation in the latest version of GHC.type. Yeah, that's where we get type from. GHC.type is a kind of thing like int and maybe bool. It classifies the sort of things that exist at runtime. Okay. Some things which aren't of the kind types are maybe without a type parameter. Yeah. Okay. So that'll explain why maybe isn't a type. And show. Yep, that makes sense. Sometimes we call this sort of thing call the sorts of things which have kind types value types. Okay. Shall we repeat that sentence? Sometimes we call the sorts of things which have kind type values, or we call them value types. Maybe we should have a little comma there. Value types. Yeah. In this book we will typeset kinds in small caps in order to differentiate them from regular types. Okay, so kinds are going to be, like I mentioned before. Note that this is merely convention for the printing process. This kind of type should still be written as, like that. Type in Haskell source file. Okay. Arrow kinds. It doesn't go too in depth with arrow kinds, but let's just do it anyway. This book assumes you already have a working knowledge of the standard Haskell kinds. Type and arrow. Yep. As such, we will not dally here any more than is strictly necessary. High kinded types, Herkötter, are those which have type variables. Fully saturated high kind types in everyday Haskell always has the kind type, which means that their type constructors do not. We should have given like a little example before. I think what it's saying is I don't know. Let's have the old classic poop. We can just have there we go. Okay, so it's saying the constructors of this, they're not of type. So what it's saying, let's consider the meaning that their type constructors do not. They do not. Okay, let's consider maybe, which is basically, that's basically maybe, isn't it? In so many words. Okay, let's consider maybe. Because it takes a single type parameter, we say that maybe has the kind type to type. So it's talking about this, isn't it? So type to type. It takes a type and gives you back a type. So that makes sense. So when you do is that right? Yeah, so it takes a type and gives you back a type. Or gives you one back. Yeah, so if you what's like a good way to explain that? It takes a type and it gives you a type. Okay, let's see if it carries on and says either takes two parameters. Okay, so it's talking about this. So you can see that's what it's talking about, this one. And if you think about either, that'll take two, won't it? So it'd be A, B, whoops, and then that'll be blah, 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 left. Oh my goodness, it is late, isn't it? Left A, and then right B. Obviously I'm giving ticks so we don't get errors. And especially when you do when you do AA, that doesn't help anyone, does it? Cool. Does that make sense? Data either A, B, and because it's expecting two types, so you think about it, they're like functions. When we're doing here on the right hand side, it's saying it takes a type, returns you a type. So here it's saying I take you a type, I'm going to return you a type, even though, yeah, and then the same here. Okay, so it takes two parameters, and so its kind is type, type, type. That's for either. Okay, actually, shall we pop it underneath? And like, except, we'll go like that because that's how you actually write it. I should have just done a multi, don't know why I didn't. We'll pop that one there. P, please? P? No? V? Yeah, that'll do. Oh look, I've got the little symbols as well, which I don't have in my, you can convert them, can't you? The arrows, but I don't have that set up. So if, but more interesting, higher kinded types are possible too. What about monad transformers? Maybe T. Or the monad transformer, maybe T. So it also takes two parameters, but unlike either, one of those parameters must be a monad. And then because monads are always of the kind type to type, then you're left with an unacceptable conclusion that maybe T, yeah, must be of kind type. Yeah, so there's a function of the monad, type to type, and then type type. Okay, don't worry if this doesn't make too much fun. Sense, but it will in a moment. So if you're not already familiar with this stuff, it will soon come to you as just naturally as type checking rules do. Yeah. So it will make more sense because I've obviously been through this chapter already, and it will make sense as to why you type. And then we start making our own things called types. So constraint kinds, because types and constraints are gonna like intertwine. So however, kinds apply to everything at a type level. So this is not at runtime. It's at compile level we're dealing with kinds. They don't exist outside of here. Yeah. Is that the best way to explain it? It's kind of hard, isn't it? Because it's like it exists where we are now, but not at runtime. Let's just draw that line there. That makes it easier to understand, doesn't it? Okay. So at the type level, not just the things we traditionally think of as types. For example, the type of show is show A, to a to string. Okay, so when we look at show itself, let's just make our own show. So it's saying it's going to be constrained to show a, and then it's a to string. Okay, and then we'll just do show, doesn't really matter, undefined, please, undefined, there we go, just for now. Okay, so this show thing, so this show thing here, this is what all of this is about. This show thing exists as part of the type signature, even though it's clearly not a type, it's a constraint, is what I was going to say, but so it's clearly not an uppercase, you know, it's not one of these from this point of view, because you know, we're over here, it's on the left, it's like a constraint. What is it? So it's clearly not a type. Does show a also have a kind? Yes, the kind is a constraint. Okay, so before we said like maybe a is of type to type, but then when you give it a type, it then becomes a constraint. I think that's what it is. Yes, it's a kind constraint. More generally, constraint is a kind of a fully saturated type class. Yeah, so I'm right. So it's basically saying, okay, so it's saying that before it was saying that poop, or maybe, confusingly called poop, should I just call it maybe, tick, you know, to stop, because, you know, I'm going to talk about poop all night. It's not going to help anyone. Cool. So it was saying maybe is of type to type. So we wrote it down here. But then when we give, you know, so when we give that type already in here, and it's already fully, saturated, then it becomes a constraint. So if we look, so if we pass show, you know, if we pass int to show, it has a kind constraint. What is a kind of show? So we can cheat with that. Well, it's not really cheating. We're gonna definitely not do it like that. I'll try. Let's do it like this then. Cannot change restart process. Yes, please. Sorry, I'm just loading the REPL. There's an error. Chapter 02. Where's our error then? That's fine. It's in the cabal. I've spelled something wrong more than likely. CH02, yes. Chapter 02, yes. Do I need to save it? Why aren't you happy? Does this need... Chapter 02, Chapter 02. Oh, is it because the other one's got CH in front of it? Let's have a look. But it has. Yeah, there we go. That's why. I named it wrong. Obviously. So let's do that. Is it all capital letters? I forgot. No, it's not. 0, 1, dot. And it's not 1, it's a 2. Come on. Wake up, wake up. Let's try again then. We could do Control C, Control R. Reloaded, okay. Okay. We'll have to do it like this then. Why are you not happy? Should we do restart? Let's do load. I don't know what I'm trying to load. We'll just load chapter 2, please. Cool. Okay. And then we'll just reload it all. Okay, we're fine. And we're going to find out that we can do this to find out kinds. And then we can do a show. There we go. Except that's still showing the old. So that's actually type to constraint, which is what we were explaining before. So if I quickly go like this, we'll go on the right hand side and then we'll go back to chapter 2, for example. Yeah. So we were saying that when, well, we did it on show because show is, actually we can just do it here. Show, whoa. Okay. Well, it's, yeah, show A on its own becomes constraint, but then we find out there's because show is waiting another value at that point, that's type. So we give it a type, and then it returns us a constraint. Okay, okay. So that makes sense. What is the kind of functor? I mean, let's just keep going, shall we? We've got a REPL. Why not use it? Okay, so yeah, so it expects a function of type to type, and then it returns us a constraint. Okay, that makes sense. Let's have a look actually. Let's, whoa, hello, look at that. Well, then what? Definitely not what I wanted. I wanted to do this. Get away from that and zoom in here, and we're going to look at functor. So you could see, look, it just takes one, an F. Oh, that's on the class. There we go. F where? And actually, how does it show us? That's just a module. Oh, here we go. Look. So the F is type to type. Ah, that's cool. Look, so it does show it here. Nice. So we have an idea. So don't worry, it will become apparent as to why we're talking about these things. But if you kind of look at it from the face value, we're able to find, you know, they're called kinds. It's different wording, but if we see that functor, the class of it is, it's like a function. It's like a type that's expected. You know, it's like you give it a type, returns a type. So you give it some sort of a function from type to type, and then it will return you a constraint. Which, you know, feels like, oh, okay, this is a bit weird, but it becomes useful. And let's do monad. There we go. Same. Let's have a look actually, because I've got a feeling that. Where are we? Monad? Monad. There. Yes. So monad M, and yeah, an M is from type to type. Okay. So that's cool. Okay, we're still following along. It's all right. It's okay. These are exercises. I should probably write them down. That might help, mightn't it? Exercise. What is it? 2.1.3. Oh, sorry, cat. She'll be out there. Well, she's definitely not outside. Poor thing, shitting her pants. Makes a change from licking a bloody arsehole all the time, doesn't it? She's now. It's got a genuine reason. Giddy. Show. Where were we? So shows kind is, here we go. Oh, I should probably, and it's not. We're going new age now, which I don't know why my. Come to think of it, what version of GHC am I on here then? Let's just quickly have a look, because I thought it would show up. Oh no, sorry, it's a bit small. So I'm on 8.8.3. Okay, so I thought the types would be in there by now, but maybe they haven't. What I'll do, sorry, just in case we use it, I'll bump that up, because you never know. Boom. Yeah, that'll do. Cool, cool. Okay. Should we just copy them, and then we're doing well. And monad transforms will be the next one. I've literally just copied everything. D. Thank you. Are they numbered by? I think they are, aren't they? Wow, what am I doing? Yes, that's better. Here we go. And it's just I, and yeah. Okay, and we're going into. Was this a good idea doing it this late at night? I don't know if my brain's working properly. Come on. Oh. My wife said something funny on telly. Yeah. I love it. I don't know what she's laughing at. I bet it's funny. Oh, I love it. Makes me giggle every time. What am I doing? V. We're going to change this to type, aren't we? There we go. Cool. So we've done, except we haven't done monad. We wanted to do monad trans, didn't we? Except I don't think it's in scope. I can't remember where. No, it's definitely not in scope. Monad comes from transformer, which I assume is control monad trans class. Okay, let's just do that for a minute. I don't know if we'll need it, but in the actual file, to be honest. But we'll bring it in. Location, what is it? The member of a hidden package transformer. But I have got it exposed, so let's just... I'm going to have to bring it in here. Oh. Okay, let's just import that for now. I thought I had monad transformers. Didn't we do it? No, we don't. We've just got containers. Okay. We'll definitely need transformers then. Okay. And then we'll shut that. And then we'll reload this. Reload my fire. Here we go. So it's rebuilding. I guess it's going to download some stuff. Oh, it's running empty. Okay, whilst it's doing that, it's going to fill this up. What's funny? Telly. Oh shit, the bed doesn't fit. Bolt doesn't fit. Be right back. No, you just sobbed it off. Sorry, it turns out the water, my tap upstairs in my bathroom doesn't fit. My bottle doesn't fit underneath. Don't know why I didn't know that, but probably because I don't fill the water from the tap upstairs too often. So we've got to bring in. It looks like it's worked, doesn't it? There's no errors. Let's have a look. Yeah, it's just saying I'm not using it. So technically, if we reload that, okay, saying it's not available, but if we try and oh, we've got monad fail and stuff, so I think it'll be in there. Let's have a look. So we'll do a kind of monad. Find it. Oh, but we can import it now, can't we? Let's just import it. Let's just recopy that. Okay, so we need to reload this then. I thought reload would do it. Failed to load. Okay, what we're going to do is we're going to say goodbye session. And we're going to say hello new session. And then if we load that file, hello Haskell, hello. And we're going to load chapter 2. And it's just going to sort of complain and say, oh yeah, you're not using it. But now we should have it in scope. I'm sure there's like a nicer... There it is. Ah, phew, thank goodness for that. There it is. So after all that, it's this. Which, when we use a monad transform, which we did last week, that should be a little bit apparent. If not, it'll be hella confusing. There we go. Cool. Okay. Let's close that. We're back. We are back. Okay. So, I mean, don't worry. We don't really hit this sort of stuff. We're more around here. I think it's just trying to, you know, send home the fact that these are basically like functions. Type level functions, really, if you think about it. So that says monad, and it was monad trans, wasn't it? Monad transformer. Cool. Okay. So we will discuss the constraint kind in much further detail later on page 61, which is further down. Without further language extension, this is the extent of the expressiveness. Oh. I look so... Oh, hello. Helleverson? Am I this? Okay, hold on. You look so much like my former employer, this guy. Welcome, Bob. Are you twins? I don't know. Let's find out. No, we're not. Got different glasses. Look, mine are like see-through. Maybe though. I don't know. I don't think he's as good looking as me, to be fair. No, we're not. That's quite a doppelganger there. From Denmark as well. Cool. No, we're not. Look at that. That is fairly uncanny, isn't it? He's got a better beard than me though. I think, yeah, mine's a bit patchy over here. We'll give it to him. Cool. What's that saying? Oh, I want to refresh it. What's this company? Let's have a little look. Office communities and companies. Nice. There we go. I just had to give my... I was renting... what was I renting? Welcome, Bob. Is he called Bob? Maybe he is called. Let's hope he's called Bob. I'm called Vince. Bob, no. I don't have a twin, but I've got a brother that's 7 years younger than me. He's called Neil. Ah, well, you know. Missed a trick there. He could have called company Welcome Neil. Niels? I think that's how you say it, isn't it? Yeah. Right, back to what we were doing. Which is maybe slight confusion. We've not really... It's been a lot of talking. We've kind of just going over this stuff. So we're just demonstrating that we can have... this is like why we get type level... they're like type level functions at the moment is what we're demonstrating. And these have a thing called kind. And then we can find those out when we open up... I'm going to do this. When we open up in a REPL. So we can just... To find out the kind of things, we can just do that. Colon K. And then we can just type in whatever. So we can do show. What's the kind of... Well, this isn't going to work. Yes, it is. It's just going to be type. Yeah. If we imagine that star is type, that'd be good. Just imagine it. Because I'm on a later version of GHC. And I don't know what versions I've actually got installed. And I use a thing called Nix as well in OS X. And that kind of like installs version of GHC, but unlike getting it, it actually builds GHC. Oh, so painful. So it takes like 4 to 6 hours, like ridiculous. It's super useful because I can just jump around. So like I was doing before, check it out. I will demonstrate this coolness. So I'm in here. I can. Oh, so we can do which GHC in here. Okay, so we see here I'm on 8.8.3. Okay, I'll jump out. We'll go into, I think maybe if we go into error. Cool, so that's now loaded up the environment from within that folder. So if I go which GHC, it might be the same version. No, see, 8.8.4. And what's the other version? What was it in? 8.8.3. Cool, so it just means I can have like multiple versions of Haskell and whatever else depending on what folder I'm in, which is really handy, but not when you have to wait. You know, it's kind of like overnight jobby. It's like, oh yeah, well I'm going to install a new version. You know, I'll just leave that on overnight. And all this stuff is I'm using a thing called dir-env here, and it basically looks at a file and then it knows I've entered. It knows my terminal's entered that file. Sorry, that folder, and then it runs Nix, and Nix just goes, I'm going to add all the stuff that you need to your path. So that's what it's basically doing. It just keeps swapping your path around, depending on which folder you're in. And then now I'm within this environment. But look, if I come out here and I go, GHC not found. It's cool, isn't it? So it is really useful, but it's a bitch to set up. That's kind of the only sort of, it's a lot better, but than say I kind of started doing it like maybe 6 months ago, maybe a little bit more. It's previous place I worked were using it, not loads, but one of them was quite a good advocate of it, and he started implementing a lot of stuff in it. So it was just like, oh well, I've got to learn it now. And then I was like, oh, actually, yeah, let's just set up my whole system using Nix. And it has benefits, but unfortunately, it's got this sort of slow you down business, which is not the best. Yeah, okay. So, next. So we were going to move on, what we're going to do in here. So without further language extension, this is extent of expressiveness of Haskell's kind system. As you can see, it's actually quite limited. Yep, we have no notion of polymorphism, of being able to determine our own kinds, or of being able to write functions. Yeah, well, sort of. But yeah, it's limited as to what they already are. Fortunately, those things are the subject matter of the remainder of this book: techniques, tools, and understanding for Haskell more esoteric language extensions. So look what that actually means. Is it like wild? Wild, I'm going to guess. Intended to likely to be understood by only a small number of people. Hey, well, yeah, this is the stuff that I think that some of it will be good in production. Some of it is best kept in libraries, and you know, that'll be the whole simple Haskell, wherever the whole argument's going on at the minute. I don't know. This sort of stuff goes over. You know, you come from different languages, and there's always some sort of a debate, isn't there? At the minute, it's simple Haskell. Whatever. Just, I don't know. Just use what you got to use, and then just don't make it too complicated, so no one understands it. That's basically it. Right. So by enabling X data kinds extension, we gain the ability. So now we're doing like data kind stuff, and this is the ability. So let's for one, let's close this. I think we can just add what was, I worked it out the other day. There's like an emit, so I can press that, and I think it was where was it? Where's jump to definition, evaluate, recompile, list errors. No. What is F? That's not going to work because I don't have it. Maybe it's Control C then. Any there? Here we go. Is it P? I forgot. Oh, I'd found it all as well. I've lost it again. I'm stopping all this so I don't have to do it by hand. But it's clearly taking way longer to just look for it. Copy, import, buffer, kill. No, okay, lost it. Another day. Do it another day. It'll be fine. Basically, actually, it'll just... We don't even need to do it because Haskell will recommend it for us once we start doing this stuff. Okay, so if we use that data kinds extension, we gain the ability to talk about kinds other than type and constraint, which is what we've been doing. So we can do more than just do this is a type, that's a constraint. This is a type, that's a constraint. Okay, and they're arrow derivatives. Okay, in particular, X data kinds lifts data constructors into type constructors, and types into kinds. Okay. What does that mean? yeah. What does that mean? As an example, let's look at the familiar type definition bool. Let's do that. And we'll go down here and we'll create our own bool, shall we? So we'll do data. This is cool actually what's coming up. So we've got data bool. We'll do tick. And that equals, let's do that. That equals true. Yeah, it equals true, or it'll equal false. Okay, so we can follow so far, can't we? That seems logical. Now, when you have, so watch this, because this is a double. I'll do it like that, and then that equals. Yeah. This is gonna. I don't know. Keep going. Please complain. Okay. Why are you not complaining? I mean, you should clearly not be happy because it wants an X data kind. Maybe I've set it up on. Yeah, that might be the case. No, it's happy. This I'll show you why. Where have I set it up? No, I don't even have it. What? That's very weird. Why is it happy with that? Not. Okay, here we go. That's better. That's better. There is some error, which is what we expect. But not right there. I mean, I could just bring in a... I was hoping that... I don't know what it's doing. Okay, anyway. Look at this madness. I think it's language. Find it? I can't. It doesn't. I don't think it has to be caps. But I can't remember. I can't remember how you set it up. Where have I got? I've got it somewhere else. I thought it'd just add it for me. Okay, well, it's definitely going to tell me it's wrong if I've got it wrong. So let's just do it that way first. I don't think it's an X. I think it's just data kinds. Ah, can't you just... Normally this all is with an S. Yes. There we go. Okay, so that's imported. Those are language extensions, but I don't know what's happening now. Whoa, okay. What I can do though is this. Where is it? There. This is my previous attempt. Is that what happens? Yes, I've got it right. Don't load it. Let's compare. Yeah, that was absolutely fine. I did well. I don't know what's going on with it. Let's just ignore it. Let's just keep going. Stuff it. Why aren't you happy? Oh, look at... No, that's okay. I think that's okay. Because we're copying that ball there, so that's fine. And then it's not happy here. That I don't understand. That does seem a little bit freaky. I think it's just like a weird one. Don't know what it's. Anyway, so in other words, via date kinds, we now can declare the types of true and false. Both of the kind bool. Okay, so now it's going to get like maybe a little bit. How can you say it? A little bit mad. So we called the tick true and tick false promoted date constructors. So okay, to be clear, data bool definition above introduces the following things into scope. Okay, so when we made this, okay, shall we just call it? There we go. Let's just do that. See if that's happy. I guess it's going to be happy now. I'm not sure if this is throwing it, but it shouldn't do it at all. Yeah. Okay, so when we made this, we put... It's available to us now. If you've got the data kinds language extension on, it gives to us these. So constructor bool of the kind type. Okay, so that makes sense. So we've got a bool of the kind type. So if we were to go... Let's just do some of this. Let's go here. Let's go reload. It's still not happy. What is wrong with you? Why aren't you happy? I'm really confused. Equal. I don't know. Or is that just not code at all? Maybe that's what the reasoning is behind it. Oh, do I need to read? Okay. Good spot. Do I need to read? Is that what's wrong with me? Yeah. Oh, you give it. Oh, see you later, Gaffer. Sorry, I didn't read your message. Have fun figuring it out. Yeah, I bloody need it, don't I? Oh, so it's not. Yeah, I thought I was getting confused. I was like, I've never seen kind before like that. Okay, so that makes bleeding sense. Where does it say it? Does it say it up here? So, though, note this is not legal. Just read it, really. All I had to do is... That must have been frustrating. You must have been watching me going, okay, he'll work it out soon. Anytime now, he'll work it out. And no, he doesn't. Because as per usual, I just want to look at the code. I don't read the text. Okay. So note that this is not a legal Haskell syntax. Okay, so totally why it didn't work. But technically it's just saying that this is then exposed to us. So I was like, okay, well that makes sense. I've seen this in later chapters that you can clearly do this sort of stuff. But I couldn't understand why. Okay, so we don't really need any of this stuff. But anyway, so you get a type constructor bool of the kind type. You get a data constructor true of the type bool. Okay, this all makes sense. This is what you'd get by just declaring bool on its own. Okay, and you get another data constructor false of the type bool. Okay, so we understand that a bool like that has the kind type, but then show A has the kind type to constraint, but because bool's like fully done, then that becomes just a type. Yeah, makes sense. Makes sense. So, however, when data kinds is enabled, our definition bool also introduces the following into scope. So a new kind bool, yep. So which is, I've just got rid of it. A kind of bool, yep. A promoted data constructor of tick true, and that's of the kind bool as well, okay. And another promoted data constructor false, and that's also of the kind bool. Okay, so we're just swapping, you know, the wording really. So that becomes a kind, and that becomes a kind as well. Cool, makes sense. The apostrophes on true and false are known as ticks. Oh, there we go. I named them right, and are used to distinguish promoted data constructors from everyday type constructors. Yes, you need to know, don't you? Because clearly one's different from the other. Because promoted data constructor exists in the same namespace as type constructors, these ticks aid in differentiating the two. Yep, strictly speaking, the ticks aren't always necessary, but consider the common case of a type with a single data constructor. So data unit. In this example, it's very important to differentiate between the type constructor unit of the kind type. Yeah. And the promoted constructor unit. Yeah, because they're both named exactly the same. First and foremost, you'll get confused in that. And then when you try and do kinds in them, then it's just going to be like, what? So this is, when you do that, that will be of the kind unit, which would, yep. And then the constructor unit would be of the kind type. Okay, so we get that. That's fine. This is a subtle point and can often lead to inscrutable compiler errors. Yeah, crazy compiler errors. While it's fine to ask for values of the type maybe unit, it's a kind error to ask for maybe tick unit, because tick unit is the wrong kind. Yes, I think, yeah, because maybe wouldn't. You're trying to pass like a kind, but this maybe expects a type, but you're actually giving it a kind, which is not what you want. Yeah, that makes sense. So we remember from here, look, maybe, oh, it's not here. Do we do it? Yeah, maybe expects a type, returns a type, and then when it's in using, yeah, so, but isn't it, I thought it'd be type and it return constraint, which is much like show. Okay, but anyway, that's clearly tick unit is not, that expects a type. So if we were to give it tick unit, that's not a type, that's a kind. Yeah, because unit is the wrong kind. Cool. Let's return to the question of the importance of data kinds. Type level programming in Haskell without them is the equivalent of programming in a dynamically typed language. Oh, that's a bit of a dig, isn't it there? By default, having every kind you manipulate by type is a lot like having all of your terms be the same type. Okay. While types don't let you do anything you couldn't otherwise, they sure make it easier to reason about your program. Oh, types itself, yes, okay. Data kinds are exactly the same. As we write more and more interesting type level programs, we'll use kind signatures to restrict the sorts of types we can be dealing with. Okay. I don't remember there being this much like literature. I thought it was a load more code, but I guess there wasn't. That's just me. Promoted data constructors are of the wrong kind to ever exist at runtime. Okay, so the promoted data constructors, which was our ticks, they're of the wrong kind. So this is literally why it's at type level. It's not. None of these ever become apparent at runtime. So then, which raises the questions: what are they good for? what good are they? It's a little too soon to answer this in full glory, but without any of the fancy type level machinery, we can use them as phantom. We can use them as phantom parameters. Okay, so we'll see what that is. Imagine an application for managing sensitive data, which has built-in administrative functionality. Because it would be particularly bad if we accidentally leaked admin functionality to a non-admins, we decide to turn a business logic error into a type error. Okay, so this is the ability to, the idea being is when you start actually genuinely type a function out, and then you'll get a type error before it's even gone to production, which is cool, isn't it? So you can set these up, and people that are coding in your code base will receive a type error rather than, yeah, wow, okay. And ask the type system, so we're telling the type system, you give me a decent error when something isn't quite right. So we're going to see an example. So we can provide a user type, should have named it something. Okay, definitely don't play the game where you have to drink something alcoholic every time, or unless, if this stream's a little bit too boring, then you can. Drink a shot of whatever alcoholic drink you prefer every time I say the word type. And let me know how you get on. So, okay, so we provide a user type whose only purpose is to give us access to a promoted data constructor. I won't type these out because said types up because it's just to show examples. So we've got a data user type, and it's literally some type of user and admin. Okay, then we can change our user type so that each user potentially has an administration token. Okay, so then so there's user, and then within user, so that's the data user is equal to user, and it's got a constructor of user admin token, and that is of maybe proxy admin. There. So it's talking to that kind, which was called a kind constructor. Is that what was the name of it? I think that's what it said, didn't it? Yeah, I'm pretty sure it's called either. Oh, I'm going to look. Type constructor. No, not a kind. I thought it's called a promoted. Sorry, yeah, a promoted data constructor. Okay, so they're promoted when they've got a tick. Okay, promoted. I hope it's sinking in because it's not for me. And finally, we make sensitive operations required a copy of this administration token. Actually, what I got confused with was this. So you kind of think, maybe, why is that proxy? I didn't really, because I've seen, well, yeah, I don't know if proxies are different in PureScript than they are in here. I'm not sure. But yeah, there's like a little, where is it here? Let's go to that one. So a proxy is a type that holds no data, but has a phantom parameter of a arbitrary type or even kind. Yeah, so you can hold a type or a kind. Its use is to provide a type information even though there is no value available of that type, or it may be too costly to create one. So it's really, a proxy is just kind of like a holder, isn't it? Because we know that maybe takes an A, so it takes a type, but here we're giving it a kind. But we want to give maybe something, but we want to know that it's of I forgot what the saying was. I've got to say it again. A promoted data constructor. Tell you. Okay, it's sinking in. It's sinking in. Data constructor. A promoted data constructor. Okay, which is what our tick is. Tick admin. And finally, we make a sensitive operations require a copy of the administration token. Okay, so again, we're now using this phantom type proxy and admin to IO. Okay, so what that means now is when we use do sensitive things, it will explain. This minor change will cause a type error whenever do sensitive things is called without an administration token. Yep. Such an approach makes it much harder to accidentally call do sensitive things. More refined techniques such as ST trick discussed on page 93. Okay, can be used to prevent programmers from simply conjuring up an admin token whenever they might like, requiring do sensitive things to be called on behalf of an actual administrator user. Okay, so I think that's basically saying you could be more strict with it, which you find out in page 93. It's not where we're at though. Okay, here we go. List stuff seems a little bit. So promotion of built-in types. Import. Okay, let's do some of that then. Let's go to here. Let's go to here. Let's. We'll close that one for now. We're going to import. Definitely not. Honestly, I think every time I come on this stream, my keyboard I lose all ability to use it. Type list. Find it. Type. Lits. Okay, it wouldn't fill it in for me, but it's happy with it. Okay, with X data kinds enabled, yeah, we've got that enabled. Almost all, it says all, gadgets and other tricky data constructor fail to promote. Okay, well, we don't know what. Well, we do know what. No, hold on. This goes into gadgets later, so I guess we don't know what they are. So almost all types automatically promotes to kinds, including the built-in ones. Since built-in types, strings, numbers, lists, and tuples are special at the term level, at least in terms of syntax. So term was like not compile time, wasn't it? Was that what it said? I think so. We should expect them to behave oddly at the type level as well. No, so term level are special at the term level, at least in terms of syntax, but we should expect them to behave oddly at the type level as well. So I guess term level is compile time. Oh, let's just ignore it. So when playing with promoted built-in types, it's necessary to first import. Okay, so we've done that module, and then that defines the kinds themselves. Okay, as well as all of the useful type families for manipulating them. We'll cover this idea in more detail soon. Soon, probably next. So a promoted version of a string is called a symbol. Oh, okay. Symbols are not lists of characters. Symbol type literals can be written by just using a string literal in place of where this is cool actually. I've just remembered what it's about. So we're now dealing with something called, it does mash it all up, don't worry. Right now it kind of feels a little bit separated, but it starts coming together. So for example, by just using a string literal in a place where a type is expected, for example, so now we can do this stuff inside of here. Okay, and we'll set, you're gonna look for me? Here we go. Oh, don't do that. And what were we doing? X data. Find it. There we go. Cool. So we've set it in there, and we can do the kind, or k of hello. Okay. So if we look, it's just, you know, I've not imported it, but it's a symbol. Actually, let's just do it. GHC dot. What was it? Just dot types, wasn't it? Yes. Cool. What's wrong with you? Could not load module. We used something different, didn't we? Oh. Go somewhere else, please. There. Oh, it's type lit. Okay. Let's go back then. Yep, there we go. And then we can do the kind of... Oh, I've literally just pressed all the wrong buttons. Yeah, it's a bad idea to do it this late, but never mind. There we go. That looks better, doesn't it? So we know it's got... oh, I was just reading an old message, but it's actually... I thought I was being told I was doing something wrong again, but I'm not. I'm okay. I'm doing something right. Cool. So we just ran that. So we checked out the kind of the string hello, and then that says it's a symbol. Okay, interesting. It's somewhat frustrating that symbols are not merely lists of promoted characters. Okay, it means that symbols are no longer inductive types. Okay, it's impossible to deconstruct a symbol. Yes, you can't start doing things like what you'd be able to with lists. Although we are capable of concatenating them via magic append symbol primitive. Okay, so this is just showing you you can start doing crazy stuff basically. Okay, this is all like type level crazy stuff. So if we look at the kind of append symbol, so now look, we've got a function. Well, it certainly looks like a function, but it's happening for kinds. It's not a function like, you know, an int to an int to an int. It's a symbol to a symbol to a symbol. So when you use it, I guess we can use it like this, and we can do hello mate. Exclamation mark. Oh, what's wrong with you? Did I need to give it something? Oh, hold on. Oh, okay, I can only check it out by giving it... Yeah, that makes sense. I was trying to just use it like a normal function, but you can't. You can only see it like this. No, what's happened? Why are you not happy now? Oh, no. Oh. Oh, okay, look. You have to give it a type of symbol. That makes sense. Okay, let's try again. So we'll do append symbol. Yep. We'll just copy thinking, and we'll have it. Definitely don't do that. With types. Cool. And then it's of the type symbol. Yes. What do you mean? What do you mean? I've clearly followed what you've told me. I'm going to copy and paste it, and then I'm going to do this. Symbol. I don't like you. Data constructor not in scope. Append symbol. Char symbol. Have I set X? I've set that, haven't I? Clearly. Let's try again. Yeah, I have. I mean, why you not be nice to me? Come on. So I've got to say to that. I don't know. I did see it working before. It'll be something I've got wrong here. I don't know why it's not. Where is it? I don't know. Let's pretend it works though. I guess it's just something I've got going on. Additionally, we are capable of comparing symbols via the compare. Well, clearly this isn't going to... I don't get that because clearly I've got the function in scope because I can do that. Okay, so which is what we did before. And then I can do... I guess I can do this, which is the next one. It's probably going to put it on different lines. No. So we can do that. Which, okay, that's fine. And then we can do this. Oh, was I? Yeah, I think I was. It was me being dumb. Yeah, it was. It was. It literally, the only thing you can input is God. Yeah, I'm not doing too well, am I? There we go. So that will return what we were looking at. Derp. Yeah, because it's kind level. It's not just going to work like a function. You can just check it out by doing that. It is like 10:30. Maybe that's why. Maybe not the best time to be doing this sort of stuff. I'm going to keep going. I'm going to keep going to the end of the chapter. It's fine. Notice that copy symbol or CMP symbol is a kind symbol ordering. This ordering is just the X data kind promoted version of standard ordering. Okay, so it's another promoted constructor, but it's a data kind this time. Okay, so it's just copying it. Natural numbers. The promotion of numbers is a little more odd. Only the natural numbers 0 to infinity can be promoted. There are no negative fractions nor floating type level numeric literals. These natural numbers, naturally enough, are of the kind nat. Okay, so we can just look at that and that'll tell us that that's a kind of nat. Yep. Typelip defines primitives for performing arithmetic on nats with exactly the same symbolic identifier you expect to have. Using them will require enabling okay, let's set this then. Next, let's set like that. Okay, so we're setting that, and let's check the stuff out. So we can do some calculations like this. Kind calculation. Well, you lied to me. It's not going well, is it? Maybe it's like it definitely worked when I first time around I did it, but I don't know, maybe it's not happy this time around. Yeah, because that's clearly here. I'm doing a kind and then it's not happy. Cool, thanks. And I'll do that one and it's happy for that one though. Okay, why not the first one? Expected kind, so that's like type to nat to ko, but 1 plus 17 has a kind nat. Is it because of this? That looks the same. Sometimes, you know, like it brings in funny symbols. No? I don't know then. 1 plus 17 times 3. Not a clue. But the one below it works. But it's saying that, so it expected a kind, but it has a kind nat in a type there. So what if I do, how about some of that? Take that? No. Oh, hold on. illegal kind signature. Oh, give up. Keep going. Okay. Lists. But we get it. We can sort of add things. List. Imagine lists were defined as a library code without any special syntax. They'd have the definition. Yeah, so data of a list of A is either an empty list or A constant to a list of A. Okay, and in fact this is exactly what the promoted data constructor of list looks like. So when X data kinds is enabled, we get the following promoted data constructor in scope. Tick list of kind list of A. Okay, and then we also get tick cons of kind A to list of A to list of A, which makes sense because that's basically what cons does, isn't it? Used infixed as that. Cool. Okay. Now note that although we haven't yet talked about kind level polymorphism, things of kind A, or of these guys, it is more meaningful and corresponding exactly to your intuition about how polymorphism should behave. So when compared against the data constructor of list, we get list is of type of list. Okay, so that's a type of list of A. Okay, empty list. Yeah, and cons is A to list of A to list of A. With a little concentration, the promoted data constructor should make sense. Okay. Whoa. I mean, yeah, they're almost identical, apart from swapping things around. Because lists data constructor have symbolic names, they are also required X-type operators. Okay, well, I think we set that. So look, we have now. Cool. Don't worry though, GHC will helpfully remind you if you forget. Okay, there is another subtle point to be noted when dealing with list kinds. While bool is of kind type, list of bool is of kind type and described as a term level list of booleans, the type tick bool is of the kind list of types. Yes, because that's essentially a type, and that would be a list. Okay, and described as a type level list with one element, namely the type bool. So let's compare. Let's do that. So we have the kind of, we're just going to do a list of bool. And that's a bool which is a type, because stars are types. And then, but if we do a kind, not a king, of a tick, where am I? Yes, of bool. Then we get a list of. So in this scenario, because it's just we're not dealing with. So at that point it's just a type, but at this point it's a list of types. Yeah, okay, that makes sense. Further care should be taken when constructing a promoted list. Due to the way GHC Lexa parses character literals, like A, make sure you add a space after starting a promoted list. Okay, so while this, a tick and a tick of true is fine, unfortunately, when they're together, you get a parse error. Okay, that's fine. We won't sort of prove ourselves up. The quirk of Alexa often bites beginners. I think if you're doing this stuff, you're probably not a beginner, let's be honest. If you can get an unexpected syntax error when dealing with type level literals, it's literally caused by this. Okay, tuples also promote in a straightforward via the... Okay, yep. So it's another tick tuple constructor. And we can do the kind of tuple2. Let's see if we get the same results. So the kind of tick tuple 2 and a char. So sweet. So remember when we were using kinds before, a 2, all when we're dealing with kinds, all twos are naturals, and then all strings are symbols. So we're basically saying that we're returning a type level natural and symbol. Okay. So it's getting there. Tuples are promoted with a leading tick. Yeah, which is there. The aforementioned passing gotcha applies here as well. So be careful. So yes, so we can't, which it mentioned just here. So if we have a tick and then for a list, so if we were to do like this, a tick of like literally true, comma, 2, for example. Let's check out the kind. This will create a pass input error, but hopefully if we do it like this, yeah, should be happy. Yeah, so that's just demonstrating that again. Okay, now we're getting into stuff. I'm just going to look how far I've got to go. Okay, yeah, that's not too bad. I can finish that. So type level functions. Where X-dataKind really begins to shine, however, is through the introduction of closed type families. You can think of closed type families as functions at the type level. Okay. In fact, we've looked at quite a few in this chapter already. Each of those primitives I mentioned earlier in copy symbols, div, and etc. are all closed type families. The ability to write closed type families isn't merely one bestowed upon GHC developers, however. We are capable of writing our own too. So we can write our own type families, closed type families. But first, compare the regular term level function OR, which computes the Boolean OR of 2 bools. Yeah, so if we look at OR, let's quickly get rid of that. No. Let's go there then. And let's go here. Should we just type it out? Yeah, why not? I've been reading a bit too much. I'm over reading. Okay, so OR is bool to bool to bool. So if OR is true and whatever, then it's going to return as true. Or if it's false, Y is going to return as Y. Yep, that makes sense. So that's how that works. Unlike data constructors, we're unfortunately unable to automatically promote term level functions into type level ones. Yes, we can't promote functions into it. But, however, after enabling X family types, which I have right here, X type family, sorry, we can instead promote or by explicit duplication this logic and write in completely separate closed type families. Cool, let's do it. So now we're getting into the nitties. So type, family. Cool. So we've got our own OR here. And if we look, so we'll reflect. So we can take an X, which is a bool. And we can take a Y, which is also a bool. And it returns us, the OR. And when it's all fully used, then it becomes of the type bool. Okay, so where OR, so now we're using the ticks, so that refers to the what were they called? This is why I wasn't very good at academia. Promoted kind constructors or data constructors. I think they're just promote constructors. Something promoted. Well, it says promote right there. So I'm guessing. So if we use that, yeah, I don't know. Literally, we're just creating a logic, but at a type level here. So if we look, it's exactly the same, isn't it? Okay, ignoring that maybe this is a little bit confusing. But ultimately, OR, yeah, is it takes one bool, another bool, and returns us a bool. So OR takes one bool, a second bool, and when it's all fully done, it returns us a bool. Okay, And then or, because we're dealing with kind level, so now we're at kinds. Should I prefix? Oh, sorry, I didn't read your. Should you prefix it with kind? Was that like to ages ago? Oh, I didn't even spot when that was. Sorry. Oh no. What? Oh shit. I'm sorry. I've done like an accidental timeout. I pressed a button thinking it was God, I'm crap at Twitch. 4 messages were deleted. Sorry, Helverson. I've accidentally like stopped you from being able to write in chat. Yeah. I think you were talking about something earlier on and I missed it. And there's a little clock thing, so I thought, oh, I'll press that clock thing, thinking it'll show me how long ago you said that, and then stupidly it's actually just timed you out for 600 seconds, which is like 10 minutes. Oh man, that sucks. Sorry. How can I undo it? Does it let me? Don't put him back. Well, I suck. Sorry. It's you know what? God. Now I'm putting my drink in front of. Yeah. Right. Note to self: don't stream late at night, like I've just attempted to. It doesn't work, especially when you're trying to do in type level programming and you don't know how to do it. Halverson, I'm really sorry. I think we might be finished in 10 minutes, so I'm sorry, man. I've totally just pressed it. So now I know what that clock does. It means that and it deleted all your messages as well. Man, that's harsh. Honestly, Twitch, you're harsh. You could have given. It didn't even give me like a "Are you sure?" It just, I clicked it and it was like, bam, gone. Okay, line for line, or and or are analogous. Analogous. Okay, the closed type. I guess that means the same. And compared in certain respect. Yeah. The closed type family or requires a capital letter for the beginning of its name because it exists at a type level. Yeah, that makes sense. And besides having a more verbose kind signature, the two definitions proceed almost exactly in lockstep. Right. So write a closed type family to compute not. Cool. Let's try to do that then. So not, sorry, I've got to do type family not. And not will take a bool, won't it? And it literally returns us a bool. And then we can do. I mean, it's not it's not the hardest thing, I shouldn't think. We could do it. Literally, we can just do true or not. I don't know if you can do underscore. I'm gonna pretend we can't because I'm not really sure. We'll try it out, and that equals false. Okay, seems happy. It's not complained. What we can do is check something out, which I wasn't sure. Yeah, it seems happy. Okay, so I guess you can use underscore. Cool. So whilst the metaphor between type families and functions is enticing, it isn't entirely correct. Okay, so they're not like a one-for-one. The analogues break down in several ways, but the most important one is a type family must be saturated. Another way of saying this is that all the type family's parameters must be specified simultaneously. There is no currying available. Recall the map function. Okay. So we can't. Let's have a little look. There's no currying available. Oh, from within. Okay, that makes sense. Let's have a little look first. What is it trying to do? So we're capable of promoting map to the type level, but because we're unable to partially apply closed type families, map does not turn out to be particularly useful. So we can make it and it'll compile, but we can't use it. So let's just copy it. We'll have a look at okay, and we want there, and we want an F there, and we'll go there. Oh, it's all like in one. Yes. That makes sense. Cool. Yes. Okay, so look, that'll compile. So let's have a look. So it's basically when we look at map itself, let's just quickly remind ourselves. Like that. So if we look at map, it's doing the same thing, isn't it? So there's an X or an F, whatever it might be. Well, there it's an F, which is an A to B. Okay, so that matches. And then it takes another one, which is an I, which is a list of A, and then it returns us a list of B. So clearly, you know, it's the same as a map. And then if the list is empty, then return us an empty list kind. Otherwise, destructure that with maybe put it like that. Would be a bit better. Ah, see, now it's complaining. Now it's not happy. Cool. Okay, so that makes sense. No scope. Type variable fx. That's why. Okay, and then illegal operator. Where do we have an illegal operator? It's complained by okay. Cool. And then these aren't happy. I'm just gonna keep clicking. Okay. Wow, it did work. Just had to add a bunch of other stuff and then it was happy. Let's have a look. I used a compiler and I just followed it, or Haskell language server, and then it just, oh, it's just saying things are redundant, but add all these up here and then it was happy as Larry. Yeah, cool. Look at all those, get rid of them. Okay, and then we try and use it. So we're going to get the type undefined. Oh yeah, okay. And then we try and use this in here. Reload. Oh, okay. Maybe there is some issues. No, hold on. Error. Show lacks a company binding. Oh, have I just got things hanging around? Or as well. I'm trying to. Yeah. Okay. It's trying to. I don't know why it didn't find any of those though. That's weird. Well, look at that for one. We're going to call it OR. And then, how come it just made all those crazy gaps? I don't know. Don't do that. Ah, what's wrong now? It's just an error. Show tick. Okay, so what have I done here? Oh, it's up there. Oh, did I just... I don't know, probably don't need it now. Yeah. Okay. Go back here. Reload now. Sweet, we're working. Undefined there. Type undefined true. Map. Yes, so we're doing a map. Whew, my goodness. So we're mapping or true. Okay, so it expects another over a list of these promoted. Yes. So first proxy isn't available. Ugh. But oh, hello fireworks. That won't be the issue. I mean, I won't import it, but should I? No, I won't. I won't bother. But basically, This error is trying to tell us that we need to use the OR closed type family without first saturating it. We only passed it one parameter instead of the two it requires. So because here we can't ever use it partially applied, basically. It can only be used if it's fully saturated. That makes sense. So I guess if we were to say, can we use a type? I don't know if we... Does it show us an example? Let's just try it. I don't know what's going to happen here. Yeah, it's not going to do anything. Oh no, maybe I'll use kind instead. Yes. Let's try it that way. Let's do it like that. Yeah, let's try that. Okay, so it's bool. Does that make sense? Except I guess we'd expect it to... That's of kind. So what happens if we just straight call it? We can't, because it's only going to ever... Yeah, we can't just do that. So what if we do... Yeah, it's not going to find, is it? Oh, hold on. Oh, it's not going to find proxy. Okay, anyway. So unfortunately, GHC refuses to compile this program. There is nothing preventing us from writing map, but its usefulness in this form is severely limited. We are simply unable to carry closed type families. Yep. And so we can't use map to perform any interesting type level computations for us. We will later explore some techniques for working around this unfortunate limitation when we discuss first class families in chapter 10. Cool, we're in chapter 2, so that's not going to happen anytime soon. Before leaving this topic, let's look again at our definition of OR. Pay close attention to its kind signature. We write it as OR x bool y. So OR x of type bool and y of type bool rather than OR xy bool. Aha, okay. This kind of type families are tricky beast. The kind you write after the double colon is the kind of the type returned by the type family, not the kind of a type family itself. Oh, okay. Yeah. So this is basically like almost like the third arrow. If you think about it, yeah. So it's basically saying, well, build these up, and that's what foo expects this and this, and then that the whole of that will be of the type bool. Yeah, but if we were to try and do bool to bool to bool with this, well, we're saying that the return of that is just a function. Oh, but why is it wrong? So take a moment to think about the kinds of foo and bar. Whilst foo has a kind bool bool bool, bar has a kind type bool bool. Ah, yeah. That makes sense because we can only because these are these become types, don't they? Because we're at the type level. So it literally we'd want type to bool, not type bool, which is what this one does. So look, so that's like type bool. Yeah, GHC agrees. Cool, thanks GHC for agreeing with us. We'll discuss type families in more generality. Oh, literally, after this chapter I'm done. In a later chapter. For now, it's sufficient to think of closed type families as type level functions. Oh, that was good timing. Yeah, my brain is definitely out of sync. I'll apologise again, Helverson, for locking you out of chat. That's what you get for trying to help. Or it's my stupidity. Yeah, okay. Ah, you're back. Hi. 600 second you're put into the bin. Yeah, that was... I'm usually a little bit more enthusiastic. I think the idea... I was really bored and I was like, oh, I'll do some of this right now. That'd be a great idea. And really, it's a terrible idea. I just end up feeling a little bit tired. And when you're doing this sort of stuff, it is good to have someone sort of be enthusiastic to make it a little bit exciting. But yeah, I don't think I'm still probably a little bit excited. What's it just called? Haskell Exercises. Yeah, this one. There we go. And I think the idea, I didn't want to do this, because I think Vlad, I don't know if you know Vlad, another streamer, he's already done these. And these are really cool. They're just essentially what this is going on about, but it's all explained. But I got fairly far down, but I think after, I don't know, I think I got to sort of like maybe I can't remember where I got to, and I was just like, what the hell? I just couldn't understand it. Yeah, and it's a bit demoralizing as well, because I and Tom has only been doing Haskell for like, I don't know, it feels like 3 years or something, maybe a bit less. I've only been doing it for 4 years. But look, and he did it 2 years ago. Oh, surrounded by brainiacs. But I want to be out there to like hold the flames for the not so clever people, to show that it is a struggle. And this stuff really is what's attractive about Haskell. You don't really need this stuff. Type level programming to be good at production. You can get away with it. You don't. This stuff's like library level sort of things. But it's good to know, and that's what's attractive about Haskell, I guess. You can really flex it out and do more bits. But yes, I think I'm going to keep hopping back and forth, try and do like novice, intermediate, and then this is even advanced though. This is probably like what some people call intermediate, I guess. But I don't know, man. I feel like it's advanced. But there, yeah, cool. Well, I'm going to call it a day. It's a bit late, but thanks for joining. And yeah, I will see you soon. Oh, I've got to click the right buttons. See you later.